Hello, everyone, and welcome to the Moving Forward podcast, episode 8. My name is Rabi, and I'm here with my co-host, Andy Lamrock.
Hey, Rabi, how are you today?
Well, let me tell you, today I had to wake up at 5 a.m. to pick up my cousin who was coming in from Sydney. So weirdly enough, I am very energetic, but I feel like it's one of those energy hits that come with caffeine before, my body's devastated and I have to fall into my bed. But other than that, I'm feeling great.
Well, that's good. I caught you on the house party this morning for the first time in, I don't know, since the start of COVID.
That was good.
So that's a good sign.
Yeah.
Getting back to normal.
Absolutely. And it was, I'm also tired for another reason. From last episode, just to give a little bit of a background, we said that we are going to talk about quantum internet this episode, and we are. But I'd like to share just the journey of trying to learn about quantum internet and more about quantum physics, quantum mechanics, quantum computing. It is one of those things where, I've spent just countless hours watching TEDx videos, watching YouTube videos of scientists explaining it, reading articles, and it's one of those things where like you can spend 4 or 5 hours in it, and then you come out not knowing what you just read. Everything just goes way over my head. But I'm quite interested in knowing how you learn something that's this complicated, and the mentality you go into learning this kind of stuff, because you're in a business where you need to learn complicated stuff every day. Cybersecurity and networking is something that's continuously developing. So how do you go into learning something as complicated as quantum physics, for example?
Yeah, look, super question, Rabi. It is a huge field. So I try to chunk it down and really try and understand it in the bits and bytes, if you like, to get a read on exactly what this topic is. And I think that the whole notion of quantum computing, and now we're obviously here talking about quantum internet or quantum networks, etc., just adds a whole new dimension. But at the end of the day, what I try and do is chunk it down, understand some bits of it, and then translate that into simple everyday speak, or business cases or examples and things. So it creates some relevance. And a bit like, if you think about artificial intelligence, machine learning, and then, data science and even deep learning type technologies,
Yeah.
If you look at them as a stack, that sort of build out, if you like, you can understand each of individual elements, right?
Mm-hmm.
And obviously, quantum computing and quantum networks are very much like that. They sit on a common architecture. Those qubits. I think
Mm-hmm.
I've got that right. And trying to understand qubits and the behavior of qubits and the rules associated with them is a real science.
Yeah.
But what does it actually mean? Like if you take a qubit, okay,
Mm-hmm.
and you think about and compare, in a quantum computing environment, compare that to a classical environment.
Mm-hmm.
The ones and zeros are simply paired together, right? In a normal, it's either a 1 or a 0. In a quantum environment, it's a 1 and a 0. And then when you look at that, it means that the possibilities are endless.
Yeah.
So once I start to get around that, I can start to, I guess, understand quantum computing, quantum networking to a certain degree.
Exactly. I think you're reminding me a little bit of the stuff that I read. My understanding of it was like, in the classical term, you have the bits, which are what we used in classical computing, are either ones or zeros, and that's how the calculation goes from the CPU. But with quantum physics, you have a position where the quantum bits, or what we call qubits, can be in what is called in quantum physics a superposition of both at the same time. And apparently this makes calculations much quicker. It does relate to quantum physics, to the fact that an electron in quantum physics can be in two positions at the same time, which is, again, going back to how we learn these things, I don't feel like we have the language to explain these things, because when I say an electron can be in two positions at the same time, I don't really understand how that can happen. But I take it as a fact just because the experts are telling me these things.
Well, look at it a little bit different. It'd be a bit like being able to like and dislike a comment on Facebook all at the same time.
hmm hmm Yeah, that's well. Again,
Like as I said, try and bring it back to today's thinking.
yeah,
That's how I do it, right? Like,
true.
I don't think I can go deep on the science in this, right? This is a very, very specialized domain. But I
Yes,
thought about it, right?
yes.
So what if you could do multiple things at the same time? What would that be?
Mm,
Well, simply, I could like or dislike something,
yeah, and
all in the same movement.
reading about this, you really come down to a number of theories within quantum physics, like quantum entanglement. And this
Sure.
is one of the things that have been mentioned a lot that could help a lot with cybersecurity. And one of the examples that I heard is that if you have say you're a person and you have a qubit, and it's quantumly entangled to another qubit that's at the bank, you have a secure connection that's guaranteed to be secure by the laws of physics, because you know evidently in quantum physics, you cannot have three qubits entangled together. There can only be two qubits, and if you add a third qubit to entangle it, one of the qubits is going to lose the entanglement. So it seems to me we're moving towards computing and cybersecurity solutions that are limited by the physical environment, which makes it just super secure. I don't even know how you can go and hack something like that. I'm pretty sure someone smarter than me will figure it out at some point. But um, it also, it also takes me to the mentality of learning about something like this. I'm just wondering, how do you go about, when you're jumping into a topic, how do you just jump into the topic and then figure out the basis of starting from the foundation, then going into details gradually, or do you just jump into the details and then derive the foundation from there? And just my personal experience is, for example, with English. How I learned English is I watched movies and I started saying the sentences before I learned the words and the grammar. Exactly the opposite to how you would learn it in school. And I think I can speak English, so I think that worked out to a certain level. But
Sure.
how do you go into such topics? You start from the foundation, or just jump into it?
Um, Look, I actually try and look at it holistically.
Mm,
So, what are we trying to do here? Is quite often the question I ask. Right.
mm,
So rather than go, right, here's an iPhone or a Samsung mobile device, right? Okay,
mhm,
and we've all asked this question. How does it work, right?
mhm,
Well, the thing is, I don't need to know how it works. What I need to know is how to use it.
mhm.
So when I look at this technology, it's really nice and it's intriguing to understand how it works,
Yes.
but that's not what's really important. What's really important is how can I use it? And so therefore, if I'm going to use it, I start to look at the whole subject. And I think the notion of quantum computing, quantum networks, quantum internet, there's
Mhm,
a couple of things there that are really interesting for me. So what are the characteristics of this thing that are really important? And what's important here is it's instantaneous. We're moving to a world
mhm.
where everything is not just real time, but it's absolutely instantaneous. And you don't need two quantum computers if you've got a quantum internet in between them to actually run the math, run
Yeah.
these models. Okay, the network itself can do this. And I think, on a few podcasts back, I talk about the network of things, and this is what I'm talking about. We are now building networks, internets, if you like, that allow us to process instantaneous gigabytes of information, right?
Oh
Just
yeah.
crunch it and do it. And so if I go back, we talked about AI ML deep learning and data science at the beginning, right? And if I think of that as a Venn diagram, and the data science is at the heart of it, and then there's the deep learning layer, and then you get the machine learning and then the AI on the outside. The job of the AI in that case is to enable a machine to think, right? So a self-driving car, for example, right? So as much as we understand that there's multiple layers to create that machine and enable it to think, okay, what I needed to understand is, what am I actually creating here? I'm creating a self-driving car, okay? And to have a self-driving car, I need instantaneous capability to make decisions. And so quantum computing and quantum networking is critical for those things to evolve further, okay? And so that's how I look at it.
Yeah, one of the, in addition to what you said, one of the use cases that really attracted my attention is that one of the speakers who was researching quantum internet was talking about the possibility of connecting to a quantum computer as a paid service per time. So if you're, say, running a simulation, you've mentioned digital twins. I'm sure there's a lot of data that goes into that, and you can really advance it years into the future by having a quantum computer. And the interesting thing is that the future that she was seeing is that you would have a qubit that's entangled with a qubit at the quantum computer as a secure connection. So not even the quantum computer knows what type of data are you going to give it. And you will be able to, say, rent the quantum computer for an hour to do your simulation, which, I would assume with the capability of a quantum computer that would be enough depending on the experiment you're running. But, it's just a future whereby we have tremendous amount of processing power available at your fingertips. I think, I don't know of another example other than the one where I don't remember the name of the company, but they were using, they were asking people to donate their processing powers in their desktops and laptops by installing a tool on their computer that mines their GPUs and CPUs for COVID-19 vaccine research. We're looking at a future whereby such tremendous data is at your fingertips. It's just, I'm looking at something that's where all of us can be scientists from our homes and have the capability of producing something quickly.
Yeah, well, I mean, I think you're touching on something that we've seen for a while now, right? If you think about, Bitcoin, its architecture is to farm out and, farm and operate on GPUs that aren't being used. And I think, the notion of GPU farms and the notion of edge devices on networks being, available compute power and things like that is well evolved. But one of the things that I think that you're alluding to there is that what we've seen is, particularly with machine learning capabilities, which is a subset of artificial intelligence. It's the statistical layer, if you like. It's where you explore the data, and it's a lot of the crunching is done, right? Okay. What we're actually seeing is a move to have a distributed machine learning model or machine learning models now. So it means that not everything has to be centrally located. So therefore, this ability to do computations that's instantaneous is just been accelerated by those sorts of outliers. Okay, so again, how do I look and see this situation? Quantum computing, quantum networks are an evolution of what we have. I don't know we'll ever have a quantum, well, I shouldn't say we'll ever have, probably not in my lifetime, a quantum computer in our lounge room, but we may not ever need it because you have a GPU farm that you can use, and the network is going to do it as well, right? So this is super cool. So we'll be able to use these very light, thin client type windows to the world or whatever we're trying to make a machine do, and the network and these GPU farms will do all the hard work.
Yeah, and
pretty cool.
It does link to you and I have been aware of the technology of how the edge computing technology is advancing as people who work in the tech industry, and um, we we did predict that we are looking at a future where your mobile phones will have almost zero processing power because you don't
Mhm.
need it. It's most of it is probably going to be battery unless batteries evolve beyond what we expect. But we're looking at devices that are really thin that focus on the quality of your interaction with the device and the quality of your view of the device rather than computing. And all the computing is going to be done at the edge. And with quantum internet, you are looking at super secure edge computing that could really revolutionize the way we interact with our devices and the devices we buy every year.
Absolutely. So we're moving to this instantaneous um, experience that's highly secure. So that's fantastic.
Hmm.
You talked about sharing information to build a COVID vaccine. So again, throwing to how do I think about things like that. I mean, obviously, you've got Bitcoin doing something similar, sharing, and those sorts of principles. So if we start to share lots of information to solve very complex problems or challenges, I see I see society also pivoting here. This is mass community creating a better universe because it's prepared to collaborate and share. So
Hmm.
I see lots of challenges, not just in the technology, but the political arena. Are
Yeah.
our government structures, our borders, our trade alliances actually hindering us from doing this,
Hmm.
or do they even fit? Is I guess some of the questions that are in my mind when you go that far. Who owns the IP?
Hmm.
And is the IP really a byproduct of community rather than an individual or
Yeah.
an organisation or a
Yeah.
government? I don't know.
Yeah. Look, when you're looking at something as complicated as quantum computing and quantum mechanics, we definitely gonna end the conversation with a lot of questions. Super conversation, Andy. Thank you very much for being here. For those who are listening, if you are enjoying these conversations, please give us the time to give us a like or a dislike if you don't like it. Leave some feedback in the comment
All at
section
the same
below.
time.
Subscribe if you want to stay tuned with our latest. With that, we have reached the end of episode 8 of the Moving Forward podcast. Thank you all for listening and enjoy the rest of your day. Bye, everyone.